morning, Math Pen students. Welcome to the very last section in this whole book. Wow, can you believe it? Since September, you guys have done a lot of work. So this last section, 7.6, okay, it's called Properties of Systems of Linear Equations. And it's actually a really short section. There's only 2 check your understandings we're going to go over. But I'm just going to give you a brief overview here. Basically, there's going to be 3 properties that we're going to be looking at for the systems of linear equations. And I'm going to go over those with you now. And this is all on page 443 for you in your books. Okay, so the first we'll look at, and this is, a lot of this you're going to already know because we've talked about it. If 2 linear equations have the same slope, we know from previous chapters, that means they're parallel. They do not intersect, right? So if I had a graph and they're parallel, right, they're never going to touch. Okay, they're always going the same. There's going to be no solution to those, right? So if we tried to solve this linear, what's the word I'm looking for, system, there's no solution. You can't do it, okay, because they never do cross. So that's the first kind of property that we're looking at, the no solution. Okay, the next one is, what if the 2 lines have the same slope and the same y-intercept? Same slope and same y-intercept. Okay, that's kind of silly, but that really means it's the same line, doesn't it? Okay, that's the same line. Sometimes we'll see it expressed differently, right? Like one of the lines might be all the numbers, right? The coefficients might all be double of the other one, but it's still the same line, okay? This would actually have infinite, or as many as you can, forever, right? Solutions. And that's because these 2 lines are right on top of each other, right? Okay, so we'll draw it again. Where does it intersect? Every single spot you can imagine forever. That's why we say infinite solutions, okay? And these are called coincident lines because they coincide with each other, okay? Coincident lines. Coincident lines. All right, so just to review, we have the no solution because they're parallel, they never intersect. We have infinite solutions because they have the same slope and same y-intercept. It's the same line put on top of the other line, so they constantly intersect. And the last one is kind of all the other systems we've been doing so far. They have one solution, right? So every time we've been doing one, there's been one solution. One value for x, one value for y, one place where the 2 lines intersect. And this is most of the time what happens, right? And because these lines, they intersect just one time, right? So if I gave you a little graph, oh, right there, right? They intersect once. So I guess the big things to look for would be the slopes. You're going to be looking at the slopes, right? If they have the same slope, you are going to need to know if they have the same y-intercept or not to tell how many solutions. Why do I say that? If they have the same slope and different y-intercepts, like in this case, there's going to be no solution. If they have the same slope and the same y-intercept, you're going to be in this situation where there will be infinite solutions, okay? Now, what if they had the same y-intercept? Okay, so they both intercept there, but different slopes. Oh, that's kind of cool, because then we know that their point of intersection is the y-intercept, so that would be really easy to solve, okay? So think about that, look on page 443 for a little bit more information, but that's basically what this chapter is talking about. So from here, we're going to go and look at check your understanding number 1. Okay. All right, I'll encourage you to look through the example yourself, and I'm going to go through the check your understanding. So it says, determine the number of solutions, which is what we just talked about, of each linear system. Okay, so there's 3 of them here. We're going to go through each one. So let's look at that first one. So this will be A. All right, and they give us x plus y equals 3, negative 2x minus y equals negative 2. So the way we're going to figure this out, how many solutions, is we're actually going to get these into our y equals mx plus b form, or our slope-intercept form. And then we'll look at them and see what information we have. Okay, so let's go ahead. This first one, I'm going to just do it over here. Y equals, I don't want this x here. It's positive on this side, it'll be negative on the other. Negative x plus 3. That was easy. Okay, so now we've got that in our slope-intercept form. We can see our slope is negative 1. Our y-intercept over here is 3. Okay, now for this one, okay, I'm just going to do this one down below. Let's bring this negative 2x over here. You can see that we have a negative y. So remember, I told you that if this is negative, and if I want to make it positive, I can flip the signs of every single term. Or if you want to think of it the other way, I could either multiply or divide both sides by a negative, okay? So I would just get negative y equals negative 2x plus 2. Okay, so now we've changed both of our equations into our slope-intercept form. And when we look at them, do they have the same slope? No, they don't, okay? So that's right there. As soon as we don't have the same slope, we're fine. We know that there's just going to be one solution, okay? There's one solution. Now we're not going to figure out what that is, but we know we could. We could use substitution, we could use elimination, we could do graphing. Those are the ways we would solve that. Okay, so that was A. All right, so let's go to B. It's pretty straightforward. So that last one was just kind of like what you've been doing all along. All right, B says 4x plus 6y equals 10. And we have negative 2x minus 3y equals 5. Okay, so same thing. We're going to put this into our y equals mx plus b form, or our slope-intercept form. So I'll start here. I'm going to move that x over. Now I need to divide everything by 6. Okay, and then I could simplify that. I could reduce those fractions. So negative 2 over 3x plus 5 over 3. Okay, so we have reduced that down. Okay, great. Now the next thing, ooh, I just realized I left it at the negative 10. Sorry about that. Just copied it down wrong, which we do that sometimes, don't we? Okay, no big deal. All right, let's look at the next one. And again, we're looking to see if we are going to have the same slope, and then if we have the same slope, do we also have the same y-intercept? All right, so negative 3y equals 2x plus 5. Let's divide by that negative 3. Okay, great. So we've got y equals negative 2 over 3x minus 5 over 3. What? That looks the same as this one. Okay, so these lines are exactly the same. So we know that that means therefore they have infinite solutions, okay? Infinite solutions, because those lines lie right on top of each other, so they intersect constantly. All right, so that is the answer to B. And we can probably already guess what C is going to be, because the book is so good at giving us each type of example, aren't they? But let's do it just in case. Maybe not. We will find out. All right, let's get to C. Okay, C says 2x minus 4y equals negative 1, and 3x minus 6y equals 2. Okay, so let's go ahead and solve these. Negative 4y equals negative 2x minus 1. Let's divide by our negative 4. Negative 2 divided by negative 4. Negative 1 divided by negative 4. I'll just write that in. We'll just simplify that. Okay, let's simplify. A negative divided by a negative is a positive, and at the same time, 2 over 4 would be 1 over 2. So y equals 1 over 2x, or x over 2, whatever. And then we've got, this looks confusing, doesn't it? Minus over minus, that would be plus 1 over 4. Okay, or you could have done that in your head. You don't need to kind of show that step. I wouldn't normally. All right, so now we've got that one. Let's do this one. Negative 6y equals negative 3x plus 2. Let's divide by negative 6. I'm just going to do that. So that'd be negative divided by negative would be 3 over 6, which I know is 1/2. I'll show that in my next step. Plus, I'm going to make it a minus because positive divided by negative is a negative. 2 over 6. Okay, let's reduce that or simplify. 1 over 2x minus 1 over 3. Okay, let's look at the slopes first. 1/2, 1/2, they're both positive, so they have the same slope. Now we do need to find out, is the y-intercept the same or not? Because this makes a difference, okay? Y-intercept is negative 1 over 3, ooh, 1 over 4. So these two lines we know are going to be parallel because they have the same slope. So therefore, and the y-intercepts are not the same, okay, we checked that. If they were, it would be the same line, but it's not. They're parallel, so therefore, that tells us there is no solution, right? These two lines will never cross because they're parallel, right? They'll just keep going in that same direction. So we were right, no solution. Okay, so that is check your understanding on page 444. So we've gone over those 3 properties of systems of linear equations. Okay, so the big things you're going to want to do. Put your equations in your y equals mx plus b form, right? You have your slope, you have your y-intercept. Okay, first thing, look at the slopes. Are they the same? Okay, are they the same? If yes, we're going to go on and look at the y-intercept. Okay, if they're not, if no, you're going to have one solution. Okay, one solution. So if the y-intercept's from there, y-intercept's the same. So you have the same slope, or the y-intercept's the same. If yes, how many solutions will you have? Infinite, because it's the same line. Okay, infinite. If the y-intercepts are not the same, if no, you will have no solution because they are parallel. Okay, so that's a little quick recap. Put your equations into that. Look at your slopes. If they're the same, look at your y-intercept. Is that the same as well? All right, so that's it for teaching for today. Let's assign a couple questions for you to look at. Let me just grab my page with that. Okay, for today, I want you to look at, these are on page 448. Okay, and look at number 4, 6, 9, or more. I always say that because you are always welcome to look at more questions. And I'll just tell you this now, that when I give you your assignment at the end of this unit, you are going to be doing number 7. So if you feel like doing that right now, feel free, because you will be doing 7, A, B, and C. All right, that wraps us up for today. As always, if you have any questions, please reach out. Wednesdays, I'm going to be doing every Wednesday a Zoom call, optional. It's extra help if you want it, so feel free. Otherwise, happy mathing, and I hope you're all doing well. Have a good day.